to our learning goals. First of all, I can identify functions, and so you should have a heads up about that from doing your own note taking. And I can find domain and range of functions and relations. So domain and range are big vocabulary words in the math world. You have to understand them, okay? So let's start with relations and functions. What's the difference between a relation and a function? Is there any difference, or could they really be called the same thing? Or would you learn when you were doing your own notes? Is there any difference between a relation in the mathematical world and a function in the mathematical world? John?
Function is a special type of relation.
Yeah, function is a special type of a relation. So all functions are relations. All functions are relations. Well, then what's a relation? What's the definition for a relation in math? Zach?
A set of ordered pairs.
A set of ordered pairs. Okay, do we know what ordered pairs are? What's an ordered pair? What's that mean? What's an ordered pair in the math world then? Well, they do become members of a domain and a range. What makes up an ordered pair?
An X and a Y.
And an X value and a Y value. So when we have two values separated by a comma in parentheses, a value, comma, another value, separate in parentheses, that's considered an ordered pair. It's an X value and a Y value that can be plotted on a coordinate plane. So relation is a set of ordered pairs. So when we talk about functions and relations, we have to understand that any set of ordered pairs is a relation, but certain relations can also be called functions, and others can't. Only certain ones can be. A function is a special type of relation. And then when we talk about domain and range, what makes up the domain? What makes up the domain for a relation? Riley, what do you think? What makes up a domain for a relation? What did you learn when you were SQ3R?
Oh, the numbers.
Blake,
Well, they're practically all the X values that are on the corner plane.
all the X values are on the coordinate plane, not quite, but you are on the right track. The domain is made up of all the what? Noah?
The X coordinates that are on the points.
Okay, the X coordinates of the ordered pairs that make up the relation. So the X coordinates of those ordered pairs that form the relation, they make up the domain. Well, what's the range then? What's the range? Brendan?
The Y coordinates of the sets of
Aaron, what's the range?
the range is the second set of ordered coordinates.
The Y's.
So the Y values, the Y coordinates of the ordered pairs of the relation. So the X's from those ordered pairs make up a domain. The Y's from them make up the range, okay? So those are all that's just talking about how they operate. So up here we have some examples of finding domain and range. So let's do some practicing with it. You can also study those examples on your own time. So find the domain and range of each relation. How many ordered pairs does number one's relation have?
4.
4. There are actually, even though they're not written as ordered pairs right now, we have ordered pair right here, -2, 4. That's ordered pair -2, 4. We have ordered pair -1, 1. We have ordered pair 0, 0. And we have ordered pair 1, 4. So we have 4 ordered pairs that make up this relation. We are to find the domain and the range. When we do domain, we're going to write it as capital D, and then we're going to use a colon. We show domain and range in what's called set notation. So you're going to make these fancy little brackets that they should have used in the book when you were studying your lesson. And we're going to list all of the X values from that set of ordered pairs. And when we write the domain and the range, what we're going to do is we're going to write them in numerical order ascending. So we're going to start with the smallest and we're going to go to the largest. And So what would our domain be for this one? Caden, what's our domain?
I don't know.
Where's your pencil?
A pocket.
Get it out. Okay, Sage, can you tell me what the domain is?
The domain,
The domain, the x coordinates of the ordered pairs.
-2,
-2, comma,
-1,
-1,
0,
0,
1.
0, and 1, and then we close our set. Yes, thank you. Okay, how about the range then? What's our range? We're going to, range is the, which values of the coordinates, of the ordered pairs? The y values. So we're going to write the y values now, from least to greatest. So what would the range be for this one, Noah?
0, 1, 4.
0, 1, 4. Notice there were 2 4s, but we only write it one time. We only need to state it one time. 4 is one of the y values, even though it's used twice. We only state it once in our range. Same would go for the domain. If an x value shows up more than once, we only give it one time in that actual domain. Okay, you go ahead and do the next one then. What is the domain and range of that set of ordered pairs, that relation? Number 2. Remember, least to greatest.
Wait, what?
So, do you agree with me, or do you need to challenge me on mine, or do you have questions? Okay. So, in number 1, it was given to us, our relation was given to us in table form, which is a typical way to give ordered pairs. In number 2, it was just given as the notation, the way we write ordered pairs in parentheses with a comma between x value first, comma, y value. What is number 3 called? What's that display called? John?
A map.
A mapping diagram. Yeah, it's a map. It's a mapping diagram. It's showing the ordered pairs in a map. So we call it a mapping diagram. And when there's an arrow going from 0 across to 8, what is that telling us? It's ordered pair.
X is, 0 is X.
So this is ordered pair 0, 8, isn't it? And then we have ordered pair what? 1, 7,
2, 6.
1, 7, 2, 6, and 3, 5. So we really still have a relation here. It's just instead of showing it as ordered pairs or in table form, they're just showing it in a mapping diagram. Okay? So we can still give the domain and range for this. So our domain is what? What is our domain, Monisha?
0, 1, 2, 3.
Done? Okay. Our domain, the x values, numerical order, ascending, in set notation. Noah,
5, 6,
you're already giving me right now
a range.
the range. Okay, 5, 6,
7,
7,
8.
8. End of set?
Yep.
Okay. Here we go. Okay, you try number 4 now. What's the domain for number 4? What's the range for number 4? By the way, when they do a mapping diagram, the first oval, or however they draw it in, is the x values, and arrow it over to the y values. Okay, help me out, Cameron. What's the domain for this one?
-3, -4, -5.
Okay, but we want them in numerical order ascending. So that's the way they came in the mapping diagram, but we're gonna put on this. Noah? Okay, go ahead, Cameron, finish it.
-5, -1, -3.
Okay, yeah, we're gonna reverse the order so that they're in numerical order ascending. Okay, and what's the range for this one, Noah?
10, 11, 12, 13.
Tell me, how many ordered pairs are there in this relation? How many ordered pairs are there in this relation?
4.
There are 4 of them. We happen to have a x value that has 2 different y values. So we have ordered pair -411 and ordered pair -412. So we actually have 4 ordered pairs, but again, we don't repeat those x's in our domain. Okay, anybody have any questions about that? Here are the trickier ones coming up. Okay, we have a graph here, and on our graph we have a line segment, and we're supposed to give the domain and the range that that graph represents. How many ordered pairs does that graph have, that relation have?
1.
Number 5. How many ordered pairs does that relation have?
2.
5, 2,
2.
1. You're all wrong.
3.
3. You're still wrong. How many points do you think it takes to make up that line segment?
5.
There are 2 endpoints, but how many other points are there in between those 2 endpoints?
Unlimited.
Unlimited. There's an infinite number of points. They're so close to each other, and there's so many of them, we couldn't even list them all. So there's an infinite number of points there. So can we list all of the ordered pairs that would make that line segment? No. So if we can't list the ordered pairs, then that means we can't really list the x values for the domain either. So what we're going to have to do is we're going to have to write it as a range of x values. That should sound like a compound inequality to you, a range. Okay? So what we're going to do is we're going to say x can go from here to here. Here's what the x values are for those ordered pairs. So it'd be good to know what are the ordered pair names for the endpoints. So what's the ordered pair name for this point right here? Go ahead, put that point on your graph and let's name it. What is it?
-2, 1.
-2, 1. And at the other end of our line segment, what's our ordered pair endpoint?
2, 4.
2, 4. So we need the range for the domain, we need the range of x values that would cover any x value between those 2 endpoints, including those 2 endpoints. So anybody think they know how we could write the domain? Let's first of all get started here. What could I write, what could you write that would show the domain for that line segment? Yes, Mitch?
-2 is less than or equal to x, less than or equal to 2.
Very good, that's exactly it. Compound and inequality, remember and inequalities? They're between 2 endpoints. We include the endpoints in this one. So we have the equal to bars there also. Okay, now let's do our range. Our range is also going to have to be, our range is also going to have to be a range of y values. It's going to have to be written as a compound and inequality. So what would that look like? John?
1 is less than or equal to y, which is less than or equal to 4.
I'm waiting. Okay, that's it. The smallest y value is 1, the largest y value is 4. This is the range, so we have a y instead of an x in our compound and inequality, and we do need to include those endpoints, those y values. Okay, why don't you go ahead and try number 6 now on your own, since you've got this. really good place to start on this would be to identify those vertices of that rectangle. They're like endpoints. So who wants to be the brave soul to give us the domain? Right, are you ready, Riley?
Yeah. Negative 3 is less than or equal to x is less than or equal to 2.
That's it. Good job. The x values, that's the horizontal. How far can it go horizontally on the graph? It doesn't go out any further than -3 on the left. It doesn't go out any further than +2 on the right. There's our domain for this one. What's our range for this one? Tyler.
1 is less than or equal to y, which is less than or equal to 3.
That's it. It doesn't go any higher than 3. It doesn't go any lower than 1. This is y. The range of the y is the vertical. So our points that help make up this rectangle are defined by the ranges. Okay, any questions? Any part of this that you would need to go back and we need to talk about a little bit before we do move on? Okay, hearing none, I must be safe to assume you know what you're doing. Okay, a function is a special type of relation, remember. So a function is a set of ordered pairs also. But what makes it special? You need to do something that shows you, okay, so circle the word function here. I don't know how well you took this in your notes, and hopefully it's done really well in your notes also. A function is a relation where each x value, and that's important, it's the x value that controls things. Okay, so each x value can be paired with only one y value. Each x can only have one y. This is probably one of the more challenging things students just can't wrap their heads around. How do you decide if it's a function or not? Okay? So let's look at our graph here where they show this one is a function, and I have a little extra on there. There are 4 points on that in that relation, and they say it is a function. And they say it's a function because each x value, when x is 2, it only has one y value, 3. When x is 3, it only has one y value, 4. When x is 4, it only has one y value, 4. Doesn't matter that it's the same y value as 3 had, it only has 1. And when x is 5, y is 6. It only has the one y value. So, and then in the mapping diagram, notice what they show. How many ordered pairs do we have in that map, in that relation? There are 4. We have ordered pair what? 2, 4. Ordered pair? 7, 4. Ordered pair? 8, 6. And ordered pair? And each of those x values only has one y value. When x is 2, it only has one y value. It's 4. When x is 7, it only has one y value, 4. In other words, there's only one arrow going from each of the x values to a y value. Even though the couple of the x values share the same y value, that does not matter. And notice now on the other side where they say these are not functions. So it says 6 is paired with both 2 and 3. It has 2 different y values. When x is 6, y is 2 and y is 3. And when you're identifying and saying whether they're functions or not, you don't get to just say function or not a function and take a 50-50 chance that you're right. You have to explain why. You have to give reasons. So here's their reason. 6 is paired with 2 and 3. Okay, here's their reason for this one. 3 is paired with 4 and 6. There are 2 points that have the same x value of 3, but yet they have different y values. And then notice what it looks like in a mapping diagram, right here. When we have -6, it's has an arrow going to two different y values. So it's not a function. Still a relation. All three of those are still relations. They're just not functions. Okay, so let's try some of these on our own here. Number 7. Tell whether the relation is a function and explain. What do you think? Is that table of ordered pairs, that relation, a function? No? Why not, Jet?
There is no pairs, they're the same numbers.
Okay, which ones? Which ones
X
make it?
value.
Okay, which x value? What's the problem? In other words, if it's not a function, which x value has more than one y value? What's the problem, Candace?
-3 is paired with 2 and 3.
Yeah, when x is -3, y is 2 and 3. We can't have two different y values. We can only have one y value. Okay, how about number 8? Number 8 a function or not a function?
Yes.
I asked 2 things, so we can't just say yes. Is number 8 a function?
Yes,
No.
because there aren't any x values jumbled up that have more than
Okay, so anybody want to agree with Seichi? Says, you know what, this is a function. There aren't any x values that have more than one y value. Anybody want to disagree and want to support your claim? And the rest of you are just going to let us figure it out for you. Huh. So, give me when x is equal to 4, what's its y value? 5. Does it have any other y values? Okay. When x is equal to 8, what's its y value? 5. Does it have any other y values? No. When x is equal to 12, what's its y value? 10. Does it have any other y values? No. When x is equal to 16, what's y? 15. Does it have any other y values? No, this is a function. So we would say function, and we would give our reason. Each x has only one y. Each x only has one y. In other words, the domain values can only be paired up with one range value. Any questions on either of those two? Okay, then let's go down to our triangle here. Is that a function?
Yes.
Yes. Okay, support your claim for yes. We're going to say function, and what's our reasoning? John?
Function, because when x is 3, y is 3 and -1.
So it is a function then, because when x is 3, y is
I mean, no,
not a function.
this one.
So I think this is the one you just said. When x is 3, we have that point, and we have this point.
Yep.
Yeah. This is 3, 3, and this is ordered pair 3, -1. When x is 3, there are two different y values. Does that ever happen again in the graph?
Yeah.
About how many more times?
Infinity.
An infinite number of times. And in other words, in fact, anytime x is between what and what, there's always going to be two y values on this, in this relation. When x is between what and what?
2 sides.
Okay, let's go over here to this one, this point right here. What's that one's ordered pair name? 1, -1? Is this? Does it, when x is equal to 1, does it have any other y values? No. Okay. How about over here? What's this one's ordered pair name? 5, -1. When x is equal to 5, does it have any other y values other than that -1? When x is equal to 5? No. Okay, well, what other x values do then? You just told me there were an infinite number of them that do. Well, I just found a couple that don't. So what are the ones that do then? Aaron?
Say like, in between the 1 and the 2.
In between the 1 and the 2, okay, between the 1 and the 2, we could, maybe at 1.5, we could see we have a couple of them. Okay, well, there's one of the infinite.
And then anything else between the 1 and the 2?
Anything else between the 1 and the 2? Is that all?
No.
Is that my whole infinite group? John?
Anything in between 1 and 5?
Anything between 1 and 5 is going to have 2 y values. Anything between, you can go above and you can pick another point out that's another y value. So we're going to say this one is not a function. When x is greater than 1, less than 5, right? Isn't that what we just said, between 1 and 5? But do we include 1 and 5?
No.
No, because remember, they only have one y value. When x is between 1 and 5, there are 2 y values for each x. So again, you don't get to just write function, not function, because, or something lame like that. You have to show you have an understanding of this. So do we have any questions about it before we move on? Okay, let's go to our last page then. Other thing you're going to be doing today is you're going to know how to make different, show the different ways that you can express a relation and or a function. Okay, so number 1, when we put it in a table, the x value that belongs with a certain y value, they have to pair up in the table. So what we're going to do is we're going to go from least to greatest in the table for the x values. Okay? So we're just going to look at the x values and we're going to say, okay, what's the smallest of those?
-2.
-2 is smaller than -1. Well, ordered pair, that has to stay with 5. What's next? -1. And we have 2 -1s, so we'll put -1 twice. One time when x is -1, y is +1, and the other time y is -2.
Once you go,
No, we're only keeping the x's in numerical order here.
Would it matter though?
Would it matter? No, it would not matter. These two could switch up. They could switch up. That would not be a big deal. Okay? And then, last but not least, we have our ordered pair 3, 1. Okay, tell me right now, just looking at that table, is this a function?
Yes, it is.
All in favor, if it is a function, hands up in the air proudly. It is a function. About a handful of you. Not a function. Okay, convince us why it's not a function then, all at the majority. Why is it not a function? Candace?
Because there's 2 -1s on the x.
Okay, so when x is -1, what's true?
It's also 1.
It has 2 different y values, doesn't it? Look at right here. It's right here. It shows it right here. When x is -1, we got 2 different y values. It's not a function. Okay, let's graph those. Go ahead. You know how to graph, right? So graph your ordered pairs. When we graph, we go left or right through the x value, and then from there we go up or down doing the y values, correct? When you're done, see if you agree with my points on the graph. I might be wrong.
You're right.
you're,
No, you got it.
I got it?
There you go.
wait, no, you don't.
Yes, you do.
Yeah, it's my notes are wrong. I'm looking at my notes. I gotta get those straightened out. Okay, how does the graph show it's not a function? How does the graph show it? No?
There are 2 points that are vertical.
Yeah, there are 2 points that are, on top of each other basically, or lined up at one above or below the other. That means they have to share the same y value if they're like that, okay? Okay, in a mapping diagram, what we do is we do it as if we're stating the domain, okay? So maybe it'd be easier for you to, before you make the mapping diagram, to write down the domain and the range, and then you can map it using it that way. So maybe we should just try, it'll give us some practice here anyway, doing the domain and range, because a mapping diagram, according to how I teach it anyway, looks just like your domain and range. Okay, so what's our domain for this one?
-2, -1, 3.
Okay, so we would put those in our left column of our mapping diagram, in that order. And then, what's the range?
-2, 1, 5.
-2, 1, 5. So in that order, we would put these over here, -2, 1, 5. And now we still have to map. It was kind of like, we set it up, now we still have to do the mapping. -2 maps to what? To 5. Okay, so we put an arrow going down to 5. -1 maps to
-2, 1.
both -2 and 1, so we have to map it to both of them. And then 3 maps to 1. So a mapping diagram can get busy. But it's really just another way of showing the domain and the range also. Okay, you do the next one, number 2. Go ahead and do all of them. Do the table, like we did, do the graph, and do the mapping diagram. When you're done, you can look up and see if you agree with me or if I need to be challenged. While you're at it, would you decide that this is a function?
Yes, it is.
Just everybody decide on your own, is this a function or not? And remember reasons why, so. Aaron?
I think it is a function
Okay, why?
because they're all different x values. And in a function, you have to have one of every x, or you can't have multiple of the same x value.
You can have multiple of the same x value. That's not really quite the defining reason. What's the defining reason why it is a function? That's the part that we gotta make sure we keep this straight in our head. An x value can be repeated more than once, and it doesn't always necessarily have different y values, okay? Tyler?
Each domain is matched with one y value.
Yeah. Each domain value has only one y value. Each x only has one y value. So we don't have to worry about whether the x's are the same or we have all different x's. Here's the reason, because each x value has only one y value. That's the reason it's a function. Noah?
Oh, I was about to say that there are also no points that are vertical to each other.
Yeah, and there are no points that are above or below each other. They line up horizontally, showing every single one of them. There's different x values, but only one y value for each of those x values, because there's no other point sharing it in the vertical range. Okay, so good. Okay, so anybody have any questions about that one? Okay, let's try numbers 3, 4, and 5 now, where we're doing a little bit of, everything we kind of have done. Give the domain and range of each relation. Tell whether the relation is a function and explain. Okay, what's the domain for that relation. Is that a continuous or a discrete graph, by the way?
Continuous.
That's continuous. Oh, I wonder when, back on the other page, when we had a continuous graph, how did we have to write the domain? Sage?
Like a, inequality.
And what kind of inequality?
I forgot the name.
Blake, what kind? A compound inequality. So, I'm thinking this is continuous, I'm gonna have to write a compound inequality for the domain. Anybody wanna offer up what they think I should write for it? Sage?
0 is less than or equal to x, which is less than or equal to 4.
Okay. And how'd you get that, Sage?
I just looked at the graph, saw where the points were,
Which points?
the endpoints.
The endpoints, that's a really important part of this, isn't it? The endpoints. What's the ordered pair name for the lower endpoint? 0, 0. What's the ordered pair name for the other one? 4, 4. Okay. So, do you think Sage has a good domain? He does. Okay. How about the range?
I think it'd just be the same.
It'd be the same. Oh, okay. So I'm going to write 0 is less than or equal to x is less than or equal to 4.
No, just you have to put y in front.
Oh, yeah, we got to remember that the range is made up of the y's, but it would actually have the same range. It's just that these are y's now instead of x's, aren't they? Okay, is this a function?
Yeah.
Yeah.
Yeah? Okay, how do you know if I look at this graph? How do you know? Noah, could you help him out here?
What?
Why is this a function looking at the graph?
There are no vertical. There are no points that are vertical.
There are no points above or below each other. There's only one point. Every point on that line segment does not have another point above or below it. In other words, another point that has the same x value, but a different y value. Okay, so because there are no other points, they're all just there's only one x value, and all those x values are between 0 and 4 inclusive. Every one of those x values has only one y value. Aaron.
So you can either say because there's no points above or below it, or because each x value has its own y value.
Yeah, you could say it either way, because each point has no other point above or below it. Or you could say each x value has only one y value. And you have to make sense when you say these, when you give your explanations. Okay, I'm going to be fussy. I got to make sure I understand what you're trying to tell me, that I really believe you know what you're talking about, in other words. Okay? Okay, what's our, in number 4, what's our domain? Tyler?
8 and 9.
8 and 9. In that order, because we do it numerically from smallest to greatest. I'm not making very fancy, nice brackets here. The way that they really look is like this. It's like a little parenthesis with a sideways V and another parenthesis. But I'm doing it kind of quick, and I do better with a pencil than I do with my finger on it. That's how they really actually look. Okay, what's the range for this one?
-9, -6 -3.
-9, -6, -4, -3, showing them in ascending numerical order. Pardon?
That last one's pretty good.
That is a pretty nice one, isn't it? Okay. Is this a function?
No.
No,
Why not?
because the x values share y values.
Because
Like, look at
So-
the as
Yeah.
tree.
When x is what? 8. How many y values does it have?
it has 3 y values.
There are 3 y values. So I would let that one count, because all it takes is one of the x's. It doesn't need to have really more than one. Just one of the x's has to have more than one y value. So we could say that. That could be our explanation. Oh, 3 y values. When x is 8, there are 3 y values. Well, Or you could say what? When x is 9, there are two y values, two different y values. And by the way, I'm not writing different, but they have to be different y values. If they have the same y value, in other words, if when x is equal to 9, there was an x equal 9 twice, and the y's were both -6s, that would still be a function then, because it's not different y values. Each of them only has, that x for 9 would only have one y value, it would be -6. Okay, let's look at number 5. What's our domain for number 5? What's our domain for number 5? Who haven't I picked on here today? No, Zach actually raised his hand. So, Cade, I haven't picked on you yet, have I?
I knew it.
Yeah, you knew it. Okay, what's it going to be?
0, 1, 2.
Okay. What's the range? You do the range too while you're at it? Okay, go.
4, 5, 6, 7, and 8.
Okay, so notice again, even though there was more than one in the domain and more than 1 2, we don't put them in the domain, even though in the table, I should say, there was an x value of 1 listed twice and a y value of, or an x value of 2 listed twice. We don't put it in the domain twice. Okay, is this a function?
No.
No, it's not a function at all.
Why not?
Because
Because-
1 is equal to 4 and 7.
Okay, so when x is equal to 1,
There's two y values.
there's 2 y values, or we could say when x is equal to 2, there are 2 y values. Did you have a question, Noah?
No.
Okay. When x is equal is, I'm going to say 2 this time, there are 2 y values. And I'm not going to make you write the word different, but that's really what it is, 2 different y values. Okay, this along with the SQ3R that you did should help you hopefully be successful in this lesson.